broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. This is Jeremy Henick from Isograph. Today's webinar, well, thank you for joining today's webinar. Today, we're going to be going over the reliability workbench upgrades going from 13.0.1 to 13.0.2. If you haven't had a chance to see what was added to 13.0.1, it's probably worth your time. We could answer questions offline or go over that in a different webinar or on the phone if you'd like. The 13.0.1 is certified by TUV for the ISO 26262, which might be of interest to some of you, but maybe not others. And then we've added quite a few upgrades to 13.0.2. Although we won't be releasing it as a full upgrade to version 14, there is a lot of upgrades that have been added. That's why we've set up this web meeting today. So on the phone, we have Joe Belland from our technical support team who will be demonstrating the upgrades. My name is Jeremy Henick. I kind of do our business development in North America.
Hi there, Jeremy. If you have a slide, be sure to share your screen.
Oh, is it not sharing? Tell me if you can see it, Joe.
Now I see it. Now I see it.
Oh, I won't. I was going to say I'll go back, but it's just our names, really.
Yeah.
So if you have missed some of our webinars, I noticed a lot of you have attended, several webinars. This is a list of some of the topics we've gone over in the last 6 months, maybe. A lot with the fault tree analysis, but also some information on Weibull, how to use plugins, different options for modeling LOPAs, things like that. So if you are interested, you can go to our blog, and there are recordings of all of these web meetings. We've kind of amassed quite a large amount of information at this point. So you can search on different topics under the search bar, but there is a lot of useful information in the blog if you have not been there. Just a couple of things to point out before we get started. This is just a screenshot of the GoToMeeting toolbar if you haven't used GoToWebinar, I guess I should say. I will be watching the questions dialog. If you have any questions during the meeting, please don't raise your hand. It's too hard to see that in the list. Please post the questions to that questions dialog, and I'll either answer them myself or I'll say them to Joe when it's something that the group might be interested in. We won't go over that slide. But unless you have anything else to add, Joe, I'm just going to hand over controls to you, and then you can take it from here.
Sure, okay.
Presenter now. You got that?
Yeah, let me share this one. Let me know when you can see my screen.
Okay, I can see it.
Okay. So again, this is we call it a minor release, 13.0.1 to 13.0.2. Usually minor releases have a few small features. You might have one or two small features, and they're usually, we put them out for minor bug fixes and things like that. This is an interesting one though, because it's been, I think, about a year since our last release. So this actually ended up being quite a feature rich release to the software. So there's actually quite a number of new useful features that usually this type of thing is reserved for a more major release of the software. But so that it's going to be an interesting version to look over, and I'll walk you through some of those, some of the more major features. I just sort of picked out, I think, the stuff of most general interest. Although the full new feature list and changelog will be available with the software when we get that on our website. Okay, so let's just take a look at some of the new features, some of the new things that's going along. So we'll start with the small stuff. There's just a lot of little small things throughout. Firstly is bug fixes. Now, Reliability Workbench, of course, is a very mature piece of software. I think our very first version of it was in the early 90s. The fault tree goes back to the 80s. The major system overhaul was in 2010. switched to a new development environment. So it's a very mature piece of software. So most of the bugs are very obscure things that the vast majority of users are never going to encounter. It's like a very niche feature that one or two users might run into. So as a result, I'm not really going to go through like a bug list because for most people that's going to not really make much sense. They won't most people won't even know the feature that was bugged even existed. But I'll just give a quick mention of certain things to give you an idea of some of these bug fixes. So in reports, if you wrote a user-programmed column in the report designer, there could be an I/O permission bug or error in that. That's been corrected. Another one in the fault tree module, if you're using a common cause failure model, when you edited the common cause failure model, it did not set the calculations out of date. Normally when you make a change to the fault tree, it makes the results go away when you make a change because now the results are no longer valid. The fault tree needs to be recalculated. It wasn't quite working for common cause failure models, so we've corrected that. In the prediction module, there were a couple places where you couldn't enter a negative temperature, so those have been corrected. There was an issue with the failure frequency calculation for the binomial failure model and fault tree. That's been corrected. So you can sort of get an idea of some of these bug corrections there. It's these minor niche features, which is probably the reason that they were able to persist in the software this long. Is it took a while for someone to actually track it down, use the feature in just a specific way that the bug stood out. Anyway, so that's just a few of the bugs. There's a number of corrections again that are generally some of those small things. Let's talk about some of the other feature changes and updates. Firstly, we've added a couple, or updated, I should say, a couple of the reliability prediction standards. So the Siemens SN29500 standard has been updated to the 2016 edition in the software. Likewise, the Telcordia SR332 prediction standard has been updated to issue 4. So I'm going to switch over to Reliability Workbench as soon as I can find it. There we go. And so if I go to the project options in the prediction module, you'll notice for the Telcordia setting, you now have the option of issue 4. You can also go back to the previous issues as well. So that's a couple of new features on the reliability prediction. This is another one that I actually kind of like. This is probably one of the features that I'm most excited about from a usability standpoint on the new version, is the full screen mode for the report designer. So if you've been using the reports, let me just go over to the report viewer by clicking on the report right view window. We've always had this report viewer right here, and you open up your reports, you edit them, everything within the Reliability Workbench window. Well, if you had a big report and you wanted to see as much space, it's kind of hard to get it all onto your screen. Sometimes you had to grab this bar and slide it way over just to get more space for the reports. It can be a little annoying, and you're always losing the space to the menus at the top. Well, now there's a button right here to enter full screen mode for the report designer. It just puts it up into full screen, so whatever report you have will use your entire screen. Toggle back by exiting the full screen mode. If you're in the design mode in the report designer, from the view menu, there's also an option to toggle the full screen mode. So that's from a usability perspective, it just gives you more space to play around with, and you spend a little bit less time trying to get allocate the space correctly so you can view what you need to. Next, there's been a couple changes to the DLL. There's one in particular that I, as a the small-time developer, am interested in. So if you remember our webinar on plugins, let me open an existing project just to demonstrate this. Remember, Jeremy and I had a webinar on plugins and DLL features a little while ago, and it showed a particular plugin. I'm going to come back to that. So just to give a little bit of history on the plugins, plugins are an offshoot of our DLL capability. The DLL allows you to write your own program that interfaces with Reliability Workbench. The way the DLL works is you basically get a copy of all of the information in a Reliability Workbench project. You have access to certain functions like to perform analysis and things like that. This allows you to write a program that will build a fault tree, make changes to a fault tree, run the analysis, and get the results. So you can do that programmatically rather than, so you can do lots of changes, lots of minor changes, or integrate it with another piece of software. So the plugin is sort of a development of that, except it's run internally from within Reliability Workbench. You can write a plugin. However, since it was related to the DLL, when you ran a plugin, what you got was a copy of all the data in the project file. So you get like a list of the gates, the events, failure data, things like that. What you did not get was anything related to the Reliability Workbench user interface, because the DLL was designed to be used without the user interface. So whatever the user is doing, however you're interacting with the program, is not relevant or not viewable by the plugins. Well, we've added a new feature that allows you to see what's selected in the user interface. So that means if I click on an item in the diagram or on the project tree on the left-hand side, I now have a new function that I can call in my plugin that will tell me what has been selected. So I can run some code directly on a selection in the UI, and that sort of speeds it up. Before my plugin, going back to my common cause failure plugin that I had written before, remember the way this plugin works is it will color events based on their attached common cause failure model. Before I had to write it, I had to present a new dialog that allowed the user to choose between different common cause failure models. Well, I can do away with this dialog now. I can just directly detect which common cause failure model the user has selected. So the user selected the common cause failure model from the project tree on the left-hand side. I've now written a new plugin that will just read that section. It will detect what the user has selected and allow you to change the color for it. So I'll choose a nice red color, and events using that common cause failure model will now be colored. So again, it's kind of, I mean, I'm probably one of the person who's most excited about this, but it allows me to simplify the plugin, simplify the user interface, so you can directly act on the current selection. Okay. The allocation module has received a number of updates. Firstly, the allocation module is now supported in data linking. Before, allocation sort of sat separately on its own, apart from everything else. You could build up a project and do your reliability allocation, but it wasn't really integrated into the rest of the suite the way like the prediction and the FMECA and the Fault Tree modules are. Well, that's been updated, and the data linking now applies to allocation. You can data link from either the prediction or the FMECA modules to the allocation module. This data link works in two ways. One is you can transfer the structure. You can create your allocation project by transferring a prediction structure. And secondly, you can create data links for the failure rates separately. So you can transfer prediction failure rates to the allocation module. And the last thing this allows for is verification. Since allocation is designed to determine what your failure rates should be, you could do your allocation to see what the failure rates should be, do your prediction to see what they are, and verify whether or not, there's a new verification dialog. It tells you whether or not your goal is being met. Let's take a look at that data linking. I'm going to open a prediction project for this. I have I'll just use this one. Okay, so this is just a standard reliability prediction project. What standard? It looks like I'm using the MIL standard. Yeah, MIL standard 217. Okay, so the allocation in this file was blank. I don't have anything there. I now have the ability to transfer that prediction hierarchy to allocation and build it automatically. I also have new data linking options. So there's new options for what to copy when you're transferring from prediction to allocation. For instance, subsystem blocks, component blocks, etc., delete missing blocks. And of course, as always, I'm going to assign a data link as well, so that way I can get the failure rates from the prediction. So then I go to the special functions menu, convert prediction hierarchy to allocation, gives me a confirmation, and then it will transfer I just asked it for the system blocks, not the individual component blocks. I just wanted the high level. So it transferred those all across. And then there's a separate option for transferring failure rates from the verification source. So I can transfer that, click OK, and if I open up one of these blocks in allocation, I can see I did not grab the failure rate. I might not have grabbed the failure rate for some of these. There it goes. I grabbed the failure rate for that one. I'd have to look at the others, figure out why I didn't grab it. So it grabs a failure rate for the blocks when it comes from when I transferred it from prediction. Okay, and so the point of the verification as well, I have this, the dialog in allocation has been expanded as well, and I have these verification options. So when I do my reliability allocation, it will choose a failure rate. It says this is what your failure rate needs to be in order to meet your system goal. And then you can see what the verification result is. So what's the allocated reliability? What's the verification object? And what's the reliability verification? Now, this particular file I'm not going to be able to do that on because I haven't done the reliability allocation part of it. Okay. So anyway, we've got some new options there for transferring data between prediction, FMECA, and allocation, and transferring units, or transferring failure rates as well. Along with that, there's a new allocation method. It's called the, let me go to the project options. Can't remember, extended grading, I think is what it's called. It's an expansion to method 2 of allocation. There's an extended graded allocation. If you're unfamiliar with the allocation, the method 2 allocation allows you to grade. Let me just create a new project to demonstrate this. Method 2 allocation allows you to create different grading factors, basically how complex is a particular object. That's used in determining how hard it will be to meet a failure rate target. In method 2, you can assign grading factors that are integers from 1 to 10, so basically a 1 to 10 scale of how complex or the operating time or the environment. Method 7 allocation allows you to choose floating point values for that, so you can grade something as a 1.5, or your grading factors are extended to allow floating point and exponential values. Okay, did I have one more thing? Oh, yes, lastly is the updated properties dialog in the allocation module. You might have noticed when I added a block, the parameters tab looks a little different. And also in the generals tab, we have the part number, LCN reference ID, and analyst, which can be copied from the prediction module as well, or with the data linking. So I have an updated and extra properties for allocation. Jeremy, I think I can stop there for some questions. Have there been any questions on anything so far?
Yeah, when and where are the updates available?
Sure, I was going to get to that at the very end. So we have the final version. We were just going through the final technical review of putting it up on the website. We have to just make sure, test the installation package and things like that. I spoke with the developer yesterday. He says it might be on the website as early as Monday. Although I wouldn't exactly hold on that or bet on that. But very soon, probably next week. Although we will send out an email alert when it's actually available. But I'd keep an eye out for it. It should be very, very soon. It will be available from the customer area of our website. Any other questions?
No, that's it for now.
Sure, okay. Let's move on. The next thing to have received a big update is the FMECA module of Reliability Workbench. Firstly, we've expanded the ISO 26262 capabilities. This sort of goes along with our verification, as Jeremy mentioned in the beginning. RWB 13.0.1 just recently received a TÜV certification for ISO 26262. So we've also going along with that, we've expanded the capabilities for performing ISO 26262 analysis. Let me show that. If I go to, let me open up a FMECA project. So if I select a failure mode, I have a new ISO 26262 tab on the failure mode properties dialog. This allows me to enter values for the related to the ISO 26262 failure modes effects and diagnostic analysis. So for instance, I can tell whether the failure mode is safety related, what the safe failure percentage is, what percentage of failures have a potential to violate the safety goal, and if there's a safety mechanism in place, and the prevention by the safety mechanism, etc. and also if it's a multi-point fault as well, and what the percentage of detected and perceived failures are for those multi-point faults. I think that becomes active when I specify the prevention percentage by the safety mechanism. That's when multiple point faults becomes available. So these all relate to the ISO 26262 standards, the type of failure modes, effects, and diagnostic analysis we're doing there. There was previously a way of doing this. It was a little complicated. You had to define some custom fields. We had provided a custom report that would put all of this out for you. It was just there was a number of steps you had to go through before you could do this and get all these results calculated. Now this is all just directly built in and integrated. All these calculations are built in, so it vastly simplifies the process if you're doing an ISO 26262 style FMEDA. Okay. So generally speaking, there's improved FMEDA usability in addition to that new dialog for inputting the data. There's also new grid layouts and new results, new dialog results for the FMEDA. This goes for both ISO 26262 and for IEC 61508. So we've added 2 new grid layouts for both of those for an FMEDA. So I can do an IEC style, 61508 style FMEDA, where it'll ask me questions about the dangerous failure percentage, coverage percentages, etc. And I get all the results, the detected, undetected failure rates, the safe failure fractions, and things like that. I get those in the results. For the ISO 26262, my grid changes, and I see those options. For instance, the potential to violate the safety goals, safety mechanism in place, etc. And it'll calculate things like the latent multi-point failure rate, the perceived multi-point failure rate, etc., residual fault rates, those various measures that are required by ISO 26262. Those options are available for the system level in the new results summary dialog. So when I run the analysis, before the FMECA module never had a results summary dialog. You'd usually get your results from the reports or by modifying the grid layout, but now we can view the results for the system level from the results summary dialog. This is a new feature. So we have a general system results summary, which gives us things like a total failure rate, the mean time to failure, detectable failure rate, and RPM values for the system level, for if you're doing a SAE processor design FMEA. We also have results dialogues for IEC 61508, where it will tell me the dangerous failures, the safe failures, safer detected, and the safe failure fraction for the system level, as well as an ISO 26262 results dialog, which tells us the not safety related, the safe failure percentage, the safety with potential to violate, the residual fault rate, multi-point fault rates, etc., single point and latent fault metrics. This was the big one that everyone was always asking us for, where we had to jump through a few hoops to get the results into the report designer. Now they're just directly available in the results summary dialog. Yeah, that's right, the new results summary dialog. Are there any questions on the new FMECA or FMEDA capabilities?
Yeah, let me just expand this so I can see the questions. In the ISO IEC tabs, is there a place in the help file that defines what each field represents?
Oh, right. So for the for this one, that's a good question. I haven't checked out the help file for the new version yet. These values are all defined in ISO 26262. Bring it to the help file. There should be. I haven't completely checked it out. If I go to the FMECA module, I should get something for the. I'd have to go through it. There you got some of the. It gives the abbreviation. So safe faults, failure rate, safety related, not safety related. So these are the abbreviations: single point fault, metric, residual fault. These are the abbreviations used in the results dialog, and it tells you how they're calculated.
Oh, right. So that answers it. So the S stands for failure, and then that's the calculation that is connected to the S in the dialog.
Yeah, so in that results dialog, it showed the S, that's the safe faults failure rate, is the calculations related to it, correct.
And Joe, is the F1 tab connected to this? Can you just click on F1? It'll take you to that section of the...
Yes, so for some reason it wasn't doing it. Normally you click on this button. Also pressing F1, for this dialog, it doesn't seem to be linked up yet. For most dialogs, you can just press F1 or click on the help button and it'll open the link. For this dialog, it doesn't appear to be linked up, so you can just go to the help and find the FMECA module, some of the blocks, and there's the calculations there. There we go. There's the other calculation options here. Yeah, so it's available in the help file. Okay, were there any other questions?
No, that's the only general one.
Sure, okay. And then lastly, let's get into the fault tree and talk about some of the, this is probably what most users are interested in. What are the changes to the fault tree? Again, there's been a number of small minor things that are sort of quality of life improvements. One is the ability to now delete unused events. Jump over to Reliability Workbench. I'll open a completed project. There's my fault tree cooling. So you know in the special functions we have all these delete unattached failure models, delete unattached generic parameters, all these delete unattached items where you can delete stuff that isn't being used. So if you've added a whole bunch of data, maybe imported from a library to begin with, and then now that you're done, you want to clear out all the stuff that you didn't need, or maybe at some point it got pruned from the tree. Well, there's now a delete all unattached event. So if you pruned basic events out of the tree, and you've just sort of got them floating around on the side here, you can use that delete all unattached events to remove any basic events that aren't being used. This was specifically added to deal with the issue of common cause failure models that are applied to basic events that are not in the tree. That was kind of throwing off the common cause failure calculations for some users. So now you can just say delete all unattached events, and if the event is not in the tree, it's going to be pruned and then won't affect common cause failure calculations. Next is horizontal scrolling, and this doesn't just apply to fault tree. This is anything with a diagram, RBD and Markov as well. You know that in Reliability Workbench 13.0.1, we implemented better scroll wheel support, so I can use my scroll wheel. Of course, you can't see me moving the scroll wheel on my mouse, but I can scroll up and down. I can zoom in and out by holding down the Control key and scrolling my mouse wheel in or out. I can zoom in and out. Well, now we've added, if you hold down the Shift key, and again, you can't see this, but if I hold down the Shift key on my keyboard and scroll, it does horizontal scrolling. So I can move the fault tree diagram around the page by just using the scroll wheel. There we go. So it's just a little bit of better user interface, so you don't have to click on the scroll bars, top or bottom. The label, table, and grid control. So if you have a label on the fault tree diagram, if you've been taking advantage of that feature, you can add a label on the background and edit the label, add text here. The labels are now available from the grid control. So if I go to grid or diagram in grid, one of the new tables here is FT labels. And this will apply for RBD as well. So now I can see my labels in the grid control at the bottom. Specifically, this is helpful for editing them. It's often easier to edit things from the grid control. So I can change the type. I can say whether or not it's a bitmap label, turn the bitmap on and off, make various other changes. And I can turn off the border, enter some text, all via the grid control at the bottom. It just is a little bit nicer way of making some edits there. Oh, export results to CSV. This is actually kind of a new feature that took me by surprise. I wasn't aware this one was coming until I discovered it. If I run the results, oh good, my results are up to date. I go to my results summary dialog. any of these results down here, normally, in order to get the results out, you'd go through the report designer. So you can see the summary results, importance analysis, cut sets, and appearance. Appearance is, by the way, how often that event appears in a cut set, and the order of the cut sets, if you're using that feature. All of these results are now exportable. There's a Save Results button, which will save whatever currently you have selected here. We'll save it to a CSV file. So now if I want, say, the cut sets or the system results, rather than having to go through a report, I can just, from the results summary dialog, click Save Results. Where do I want to drop this? Let's put it on my desktop. Save it. Okay. There it is. And it might take a second to update. I don't remember. Okay, there we go. So it updated. Sorry about that. So I opened it as a CSV file, so I have those cut sets in Excel right now. So again, I can do that for the cut set results, for the system summary results, the importance analysis. It's just sort of a shortcut if I just want to get that out to an Excel file, to a spreadsheet, rather than having to take the extra step of going through the report viewer, one of the built-in reports. I can just dump it straight to a CSV file. Okay.
Joe, there's one interesting question about
Sure.
the label. Can
Sure.
you tie the label to a specific gate so that if you move that gate, the label moves with it?
Yeah, we added that in 13.0.1. That was the anchored labels feature we added there. So this is an anchored label. And yeah, it'll appear to the right of the gate. The nice thing about this is that since it's tied to the fault tree will automatically account for that space when it's doing its layout algorithm. So you can have the label tied to it. You can also resize it, choose the size and height of it to resize it to fit it. You have a lot of the same label properties, changing colors and fonts and things like that. It's tied to the gate. So if I grab the gate and move it, the label goes along with it. Yeah, that was added in 13.0.1. We added anchored labels.
Thanks.
Okay, a couple changes on the event tree side of thing. One is that the frequency column can now display a unit. So if I go to my event tree, there's my event tree. So here's the initial frequency of 4. Well, what is that unit? Now I have an option of displaying that. I go to View Options and say Show Column Frequency Units. I also have to turn on the units. I think these are in years. So click OK, rerun the analysis. And now it shows 4 occurrences per year. So it's just kind of a nice little label there. So you're showing this event tree to someone. They say, "What does this 4 mean?" You can point it out. You can actually have that included on the report or on the diagram. Say what your frequency units are. That sort of matches the fault tree, where we've had the ability of showing units, calculated unit values in the failure models. In the failure model dialog and in the result summary dialog. We've had that for quite a while, the ability to show units. So now those show on the event tree diagram. Also in the event tree is the ability to, now this is kind of a cool one, the ability to trace event tree cut sets. So now, again, if you're familiar with the fault tree, you might remember the trace cut set feature for a fault tree. I can pick a cut set and use the trace set option, and we'll highlight the path in red down from the top event to the basic events that make up that cut set. We've added that same feature now to the event tree module as well. So if I'm in event trees, and I click a particular selected consequence, so greater than 8 fatalities, and select a cut set that will lead to that consequence, I can select a trace set and highlight the event tree branches leading to that consequence. So you can follow the path through the event tree that would lead to a particular end consequence. Before I get onto the IEC 61508 calculation updates, Are there any additional questions you need me to answer, Jeremy?
Yeah, that you know how you exported the summary to the CSV file?
Right.
Does that work in RBD as well?
I haven't tried it, but it should because it's the same dialog. It's the same control. Let's take a look. Results are out of date. Yep, there's the same results here in RBD as well.
Okay, thanks.
Okay, so last thing is the there's been a number of changes to the IEC 61508 calculations in the software. The first one is a new failure model. We've updated, or actually not just updated, added a new 61508 failure model. This one is called the IEC 61508 FT, or Functional Test Model. And it allows an additional functional test interval. So you might remember, if you've taken the training course, this is the math behind the calculating the PFD, or the unavailability. For the old 61508 model, you take the undetected failures times the proof test coverage. This lambda tau over 2 is the averaging for the failures that are detected by proof testing. This section here is averaging failures that are not detected by proof testing, right? The 1 minus the proof test coverage. Theta is the overhaul interval, so lambda theta over 2 is the average. And this is the detected failures, right? So the new model allows for a functional test. It's basically an additional layer of diagnostic between proof test coverage and detectable failures. So basically it allows you to now do two tests to detect faults. A functional test is just making sure the component is still online. A proof test would be a more complete making sure it still works to an extent. So now we have two segments to determine unavailability due to faults that are detected by the functional testing and faults that are not detected by functional testing but are detected by proof testing. So we've broken it down. There's now two test intervals, a functional test interval and a proof test interval. Let me jump into the software just to show the new failure model dialog. So if we go to the failure model properties, and now at the very bottom, we have the 61508 functional test model. It's largely the same as the 61508 model, except now you have two extra fields at the bottom for the functional test coverage percentage, the functional test interval. So again, it's just another layer on top of. So if you're doing a proof testing, but then you also have some other testing which can detect some failures in addition, or it can detect some failures and the proof testing detects more failures. You can account for that as well. And lastly, there's been this was a major calculation change for the 61508 averaging for the system. So if you've been using fault trees for 61508 style SIL analysis, then you're probably using the 61508 averaging. We know how this applies to dormant models and also 61508 failure models. They're the three different averaging methods you can apply: mean, max, or 61508's dormant model calculations. So there's been a new averaging method added to those three, the 61508 extended averaging. The difference between that and the regular 61508 averaging is it uses the full exponential expansion for dormant periods, as opposed to the regular 6150, which uses what's called the Maclaurin series expansion. If I can get a little technical there. To explain, I'll show where this option is set, but to explain why this is used and what the difference is, I'll have to get a little bit mathy. I hope you'll forgive me. Just to explain what's going on here, why the difference. So if you take the exponential distribution and you graph the unavailability over time, you get a plot that looks sort of like this. There's for an exponential distribution, which is what we use to model, a constant failure rate, or a component with a constant failure rate. So the graph looks a little bit like this. The equation to define this graph for a non-repairable component would be this: 1 minus e to the negative lambda t. That's the exponential equation for the unavailability, or rather the unreliability after time t. So this beginning part of the graph right here is called the transient region. During that early life of a component, this is basically a linear, it's almost a straight line up for quite a while, or not that long, but it's a straight line up at the beginning of the life until gradually it will level off. So this early life period, this transient region, can be approximated as lambda t, this part right here. So in a lot of cases, you'll see the unavailability just simply approximated as lambda t, the failure rate times time. Okay, this comes into play in dormant periods. You'll often see this graph to represent the dormant or the unavailability of a dormant component, where the unavailability is 0, and then it gradually increases until we test it. And then we reset the unavailability to 0, assuming perfect proof testing. So you get this period. I've shown this in my training. You might have seen it in some of our other videos. Now, this graph was created using that lambda t approximation. So to calculate the average value for this, we just take the lambda t over 2. This is what the IEC 61508 standard uses for a single channel. Lambda t over 2 is the approximation used for the dormant periods. So that's calculated again using lambda t, where tau is the test interval. So it's this. It's basically taking a halfway point of this. Now that's a good approximation for short test intervals if you're testing frequently. The problem is the longer you go between tests, the more likely you are to get out of that transient region on the unavailability graph, and the more likely it is to start curving downwards as it gradually reaches up. So this is what a better graph would look like for the unavailability due to dormancy. You can see it's actually curving down a little bit. Now to calculate the mean value from that, we need to take a different value. It's actually a little more complicated, basically doing integration of this graph. So that's what the new IEC extended dormant averaging is doing, is rather than using that lambda t over 2, and you remember I showed that a few slides back when I was talking about the PFD calculations for the 61508 failure model. I talked about using lambda t over 2 or lambda theta for the overhaul interval over 2 as the approximation. And again, that's what's specified in the 61508 standard. However, we had a few users who were complaining that gives a pessimistic average, because it's this lambda t over 2. Eventually, over time, you can see it goes higher, and is therefore pessimistic. So we added a more complex calculation to take into account that if the dormant period is long, the test interval is long, the graph will eventually start to curve downwards. So how does that? I'm sorry, I apologize for that little techie background for the mathematical background, but it's kind of necessary to understand the difference between these two. So let's take a look at how this will actually affect calculations. So on the left-hand side, I have a simple fault tree. I've got 2 basic event inputs. The failure rate for these is 0.1, whatever my units are, 0.1 failures per year. My test interval, my tau, is 1, so testing every year, with a failure rate of about once every 10 years. And this is what we'd get using the 61508 method of averaging. At 0.00, about a third times 10 to the negative 2. Now, of course, that's going to be a little bit pessimistic, because we're assuming the unavailability is a straight line. If we take into account the actual full exponential expansion, then we get this value. This is using the new IEC 61508 extended averaging. So you'll see you'll get a little better result. And that was the reason we included this calculation. There were some users who didn't like to use the 61508 model or the averaging, because they're saying, we're getting pessimistic results. We know that our actual SIL level, our SIL verification is actually better than what the program is giving us, and then even what the IEC standard will give, because again, it uses a lambda t over 2 approximation when it could be using something a little more accurate. So that's what we've added in, and let me just show you where that is in the software. And remember, it applies to the new 61508 FT model, it applies to the existing 61508 model, it applies to the dormant model averaging as well. And that option is chosen in the project options. Actually, let me just demonstrate this. Let me open up a completed project. Okay, let me just This one should have the regular 61508 averaging. So if I go to the Calculation tab, here's where we set the dormant model approximation, whether mean, max, or 61508. Right now it's 61508 set. That's what I used when I first created this project. So let's just do a quick comparison of the unavailability. So the longer it is between test intervals, the bigger the discrepancy. If you have really short test intervals, it's not going to be that big of a difference. Usually applies. So I'm not sure how long my test intervals are in this one. So 0.0047 is the result. So now let me, that might be hard to see on your side. Let me zoom in a little bit so you can see. I suppose I can just use the shift and scroll wheel for horizontal scrolling. Now let me change the, so there's our 0.0047. Let me change my calculation method to the 61508 extended. I'll use a more accurate exponential model. 004511. So it drops a little bit, maybe not substantially, depending on my application, but it gives me a little bit more accurate estimation. Okay. Jeremy, any questions on that?
No general questions. Any questions that don't get responded to during the meeting, we'll email you after the meeting.
Okay. Oh, we already looked at the slide. Okay. As I mentioned, it will be available for download soon. I spoke with the developer because he sent me a copy of it a few weeks ago, and I noticed it still wasn't on our customer area. So I asked him what was going on with that, and he said, "Oh, it's coming soon." It had to do with something technical. I didn't get the full story. They were just waiting on the verification, I think, for the installation package or something like that. He told me that it should be up and available soon. It's feature complete and tested, so we'll have it available. We'll send in an email to all our users when it becomes available on the customer area of our website.
Thanks, Joe. And as always, if you have any questions after the meeting or anyone that asked questions that we didn't get to, we'll email you later in the day. And if you have any suggestions for future topics, please feel free to contact either Joe or myself. And we appreciate you attending the meeting. If you have any questions or want to discuss any of this in more detail, please let us know. Thanks, Joe.
Thank you.